and I just want to explain some few things on how we can work on SPSS. So far, you have a data. Now, remember, this data was actually an Excel kind of data that I had to bring into SPSS so that I can work on it. Now, the first thing I have to do is one key thing about data analysis is that you have to understand what the data is like. Because while you're analyzing data, if there is any mistake with the data, there'll be a problem later on. So one of the key things that are important in trying to find is, well, there may be input errors. So you have a job of trying to identify if there are input errors, and then one other thing you have to do is check, does this thing actually make sense? Like based on the kind of value you are seeing, does it make sense? Right? So those are some few things you have to first take care of while working on a data. So after you input data and then you want to start to analyze it, you have to first check, does this data actually make sense? Does will it be able to do certain things I need it to do? So having now for us to be able to do that, this is the data view. Let's check the variable view to see what the variable view looks like. All right, so this is the variable view, and looking at it, the group is a string. Now under type, we can have string, we can have numeric. So string are just alphabets, like their alphabets, letters, and all those things. That's the type that we call string. And then we have numeric, that is they contain numbers. That's what we have in numeric. All right, under width, the width here is just trying to emphasize on the how wide the column is. So if you check it now, for the group, the width is 13, but for parameter it is 5. Let's check it to see how it correlates. So this is group, this is the width, and parameter, we can see that parameter is actually small. So that's why it is 5. So if you try to make it, you want to make it bigger, you can just increase and make it, let's say we want to make it 10. So we've changed it to 10. Let's check how it has reflected. So you can see now that it has, okay, it's not actively reflecting. 13, 13, let's make it 13. Right, let's have this. Am I increasing something else? Parameters, yeah. Okay. You can just like Excel, you can just widen your this thing there. So I've widened it. If I check back now, okay, it is the width is 14. If I decide to widen it more, it must have reflected here also.
To reflect,
Why is it fixed? Okay.
just continue.
All right. Okay, that should do now. Okay, so we have the width balanced already, and then some other things we have. Okay, all these are numeric. Now for the string, definitely there can be decimal places for string type of data. Please, are we still together?
Yes, we are.
All right, thank you. So for string type of data, alphabets, letters, definitely there can be anything like decimal. So that's why it is 00. And then for the numeric, we set it as two decimal places. So they are all set as two decimal places. If you want to change it, you can decide to change it here. So I'm trying to change the lever to three decimal places. Let's see what has happened. So lever, you can see now that it is now three decimal places. If I try to change it back to two decimal places back, let's check it again. It is back to two decimal places. So the variable view just gives you a place for you to work and adjust how you want your data to look like. It will be easy for you to analyze. That's what the variable view does. And then, so that's decimal. Label. Now, this part of label is just, it helps you to just remember what you're working on. So what label will not display in the data view. You won't have it in the data view. What it is just there for is just like for you to code something there so that you can remember that, okay, this is what this column actually means. All right, that is what label does. So under your label, you can just input a short statement that helps you remember what you're actually working on. That is what label does. And then these values, well, values is just trying to show the different um, classifications that we can have. That is not always used. So most times, in most cases, it is always none. Now, missing. This missing shows that do we have any missing values in the in that particular column. Don't forget that this group is a column. So group, this is a column. So it's actually a column here, right? So this variable view, what this is telling us, what is missing is telling us is that under this group variable, there are no missing values. That's what it's telling us. So looking at it all through, we can see that there are no missing values. So this is one of the quickest way you can check to see if there are missing values. So if there were to be a missing value, it will show the number of missing values here, provided there was a missing value. So it will show like, okay, we have two missing values, we have three missing values. It will show it here, right? So that is what this does. The column is similar to what we have here, similar to the width, and then they are aligned. It just helps to show how they are aligned. Oftentimes, string letters are always aligned to the left. It's just like Excel. And the fact that we actually use Excel to prepare this document, so it actually matches what we have in Excel. That's why it is displaying the properties of Excel here. Okay, so that's what we have here. So the align is just to show is this center to the left or center to the right. So if you look at the string, they are center to the left, while the numerical center to the right. Let's check it. So the strings, these are the strings, these are this, they are centered to the left, while the other ones are centered to the right. So that shows exactly what we have in the variable view. Now under the measure, we have nominal. The strings are nominal, while the other ones are scale. Now let me quickly explain what we mean by nominal and scale. Under what's it called? Under SPSS, or let me say data analysis generally, we basically work with three types of measurements. We work with three types of measurements. The first one is the nominal. Nominal are referred to as categorical data, kind of data. Yeah, let me use that word. Categorical, that is, they are category based. What we mean by category based are okay. Another thing to balance it, because the other one to ordinal to use categories, but the difference between ordinal and nominal is that nominal does not have a particular arrangement. It does not have a particular order. Let me give an example. Um, okay, we are trying to work on a particular data, and then under your data, one of the things you collected is the blood group. I mean, those blood samples, you check their blood group, and then so under the for the blood group will be a nominal data, although it is categorical in the sense that the blood group we have is either A, B, or O. All right. So that means it is categorical actually. We can't have anything outside of these particular blood groups. Yeah. But we can't exactly say this is how they follow themselves. Do you understand?
Mhm. Yeah, I think it's
Yeah.
not based on order, but it's there are different
Ex-
classes, but not based on order, not a particular order.
exactly. So for nominal, although they are categorical, but they do not have a predefined order. So there's no inherent order. We can just be arranged anyhow. That's what we have in nominal. So although it is categorical, yes, but it is not defined. Now another one we have, let me click the drop down for us to see the other one we have there. Okay. We also have, you can see, we also have ordinal. So the ordinal, because it is string will actually be either ordinal or nominal. So because it is strings are categorical. They will always be categorical. That means they are based on categories. So it's either nominal or ordinal. Now, I've explained nominal. Let me explain ordinal. Now, for ordinals have a predefined order. Those ones are orderly. Now, let me give an example. Um, okay, the earth sciences would be able to, or those that collect data, not those that work on data in the lab, probably those that go out to collect data to analyze and all those things. Now, an example of this data is okay, when you're trying to collect a data now, and then you're trying to create a condition. Let's give an example. Okay, that's a part of your questionnaire is how do you functions? You put bad, or let's say you put very bad, uh, undecided, good, very good, excellent. Now that is following an order. So there's an order to that actually, because you already classified that particular uh, um, kind of categorical data, like it is classified. There's a way you've arranged it. So that arrangement is part of what you'll be considering, what you want to analyze. So that's the difference between nominal and ordinal. In the sense that for ordinal, it follows a particular order, and that is what all those that collect questionnaires, that's what they use. A common one is the linkard skills. Linkard skills now. Education level is an example of an ordinal kind of data, because education level can either be primary, secondary, and tertiary. It is arranged. It's following an order. Without primary, you can't get to secondary, you can't get to tertiary. So there's an order to that. A satisfactory rating. That is how satisfied are you. There is very unsatisfied, there is unsatisfied, there is neutral, there is satisfied, there is very satisfied. Do you understand? I just want us to get the balance between the two. So that is how ordinal works. But for these two parameters we have, let's check the data view again for us to see. There are no particular order here, because standard is just there. There's no particular. It doesn't have to be that after standard is control or anything. No, it can be anyhow. So there's no particular order for the group. The same thing as the parameter. There are no particular order. You can decide to bring your rat 5 and bring it to rat 4. There's no order here. So it is just anyhow, and it is not dependent on themselves. That's another thing about the difference between them. Ordinal data, they are kind of they are moving up on a scale that is from very unsatisfied to very satisfied. That is the two ends that we can have. But in case of blood group, we can't say that if the beginning is AB, the end has to be O. No. So there is no order to nominal, but to ordinal there are order. Do we understand, please?
Yes, sir.
All right, so let's. I think that's what we have, and all these ones for scale measurements are the kind of measurement that you use to measure things, because scale can have decimals, that is continuous. Yeah, we can also call them continuous data. So it is continuous. So if you measure someone's height today, and the person is let's say 5.4 inches, by the time you measure the person in, let's say, 2 months, definitely the person cannot be 5.4. Either there's a reduction, which is most likely impossible, or there is an increment. Probably the person has increased to 5.45 or 5.455. So something about scale is that it is continuous. Even if it is not by a whole number, it can be continuous by the decimal places. So the decimal places may increase in scale. So those are the three types of data that we have: the nominal, the ordinal, and the scale. Please, can I have someone tell us the three types of data that we have before we continue? Anyone? All right, Mr. Adele, please, you can unmute and tell us, please.
Okay, good evening, everyone. The three type of measure that we have the nominal, we have the ordinal, and we have the scale. Thank you.
All right, thank you so much. So those are the three types. Works our data view. Now, one other things we can decide to do, although this thing is already orderly because I already worked on it, so that's why it is orderly like this. Let's assume that when you were inputting your own data, it was not orderly at all. Like everything was not orderly. You just did everything the way you want to, the way you were able to. Or let's say different people work on different things, and then you now combine it together. As per group work, you go and input this, let me input this, and when you are all done, you join everything together. So It may not be orderly, and then you're trying to get it orderly. One of the, what we do when we're trying to do that is we try to sort. We try to sort it. Sorting is just about arranging it. Like it's all about arranging it and making it follow a way you want it to. Yeah, that is how you sort. And when you're trying to sort on SPSS, so one of the things you have to do now, you have to determine how do you want to sort it. Is it based on the group or the parameters? This is sorted already, actually. But one thing you have to do is okay, what do you want to how do you want to sort your data? Do you want to sort it based on the group or you want to sort it based on the parameters? And let's assume I want to sort mine or my own, although it's sorted. This is how I worked on it. But let's say I want to rearrange it again. I want to sort it based on the group. So all you have to do to sort by group is go to data. Under data, please can we all see the screen?
Yes, we can.
Yes,
All
yes,
right.
we can see it. We can.
All right, thank you. So under data, you just go to sort cases. We're trying to sort the cases. So click on sort cases and then you want to sort it by the group. So you can push the group into the sort by. This is the sort by. And then you have ascending or descending. Now let's say we want to make it descending. That is from up, from from up to down. That's descending. So we want to make it descending. So we can click OK. All right,
Okay, I
this is
think,
just showing me.
hello, sir. I think this the
We can't see
screen
the
again. We
Yes,
stopped.
I
screen again.
yes, it was this thing was different. Can you all see it now?
No, the screen is on, right? But we couldn't see where you were saying descending or ascending. I think we followed to the point where you selected sort data, and after then we couldn't see the other steps.
Yeah,
Yes.
it was different. Sorry, let me explain. It was a different output, like a different windows opened. For this was the window that
Okay.
opened. Let me,
Mm.
yeah, that's the issue. Like another window opened to show the output, but the output will also reflect in the windows I'm actually showing. Do you understand?
Oh, okay, sir.
Yeah, a different window opened. That's why we always have output window. So the output window opened. That's why I had to come back here because this is the one we are working on. But if you actually look at it, that's reflected here. Do we observe that? Did you observe the changes that happened? Hello. Did
Sir,
anyone observe any change?
I, I don't think I saw it though, but maybe. Is it on which of the groups are we working on?
Okay, let me try to go back if that were possible. Okay, it's not undoing, but if okay, it can undo. Let me do that.
Okay.
Oh, it can't undo. But anyways, now let's I will do something like that again. Now let's
Okay.
take a look at the group. Let's take a look at all this group that we have. If you look at it, we have standard first, then we have group F, then group E, then group D. Right? That's what we have for
Mm.
now. Now, let me try to sort it again. The same thing, sort cases, and then I'm trying to sort again by group. But now I want to change it to I can bring it in again. Now I want to sort it, change it to ascending. Right? So press OK. Let me go back to my now. Can we all see the group now? Can we see the
Yes,
changes now?
yes, yes. That's changed.
Yeah, that is just exactly how. So C is now on
Okay,
top. We have
alphabetically.
S alphabetically. That is ascending. All right. So that is exactly how this sorting works. That's how you sort when you are trying to work on data. And because these are the key things you have to do, just provided that your now for my own now, I already had it following themselves initially. But provided they were not following themselves, this one way to just bring everything together. Let all your let all the group, let them be together. So that we'll not have control in row one and have another control in row 20. Let all the controls stay together. And once you do this, it will affect every other thing, every other column that we have. That's why we are sorting by the particular column. So it will affect all the other columns that we have present in it. Do you understand?
Yes, sir.
Sorry, sir.
Oh, all right.
Yes,
Okay.
sir.
All right. Thank you.
Sorry,
All
sir.
right. So, okay, you want to ask a question?
Yes, sir. Please, I didn't get where to pick the sorting, like to click on sorting.
To click on what's that?
Sorting.
Sorting. Okay, click on data under
Okay.
your toolbar. Click on data. Have you done that? Hello.
Okay. All right.
Have you gotten that now?
Yes, sir. Yes. Thank you.
All right. Okay. Yeah, you're welcome. All right. So that is how we sort data, because that's one of the key things that is to just to ensure that, oh, we have 15 minutes. Oh wow. Let me just quickly do some quick analysis for us to have an idea of what to what. Now, I already have it sorted and I've assumed that everything is perfect, because actually everything is perfect with this data. Now I want to analyze. One of the quick analysis you do, we have different type of analysis actually. We have descriptive, and we have inferential, we have predictive. Well, I'm not going to all those details. Basically, the common ones we often do are the descriptive and sometimes inferential too. When I mean under the descriptive, that's when we talk about the mean, median, mode, and all those things. While under the inferential, that's when we talk about the ANOVA, the t-test. I'm not here to tell us when to use all these things. That's not what I'm here to do. I just want to introduce us to how it's done. Now, let's assume I want to quickly do a descriptive. I want to understand what is happening to this data. What do I know about this? What can I say about this data? So, very quickly, I can use a descriptive statistics to tell me what I have. So, under the analyze, click on your descriptive and then click on descriptives. So, you can decide to pick them one after the other. So, let me pick liver first. That's what I want to describe. And then you can click on option. What are the things you want? Now, based on the default now, the default setting is that the standard deviation has been checked, the minimum has been checked, the maximum has been checked. Those are the things that have been checked. So if you want to add any other thing to it, you can click it. So let's say I want to add the range to it now. I can decide to add a range to it and continue. So by the time I view it, I will have this.
I can't see the screen from here. I don't know.
Okay, let me change the, because I will have to show the output so that we can actually see what the output is like. But do we all saw the way I carried it out?
I
I
think we
didn't see
saw it
anything
to the
from my
point
end.
where you chose analyze and then descriptive. Then probably it
Yes,
opened
yes.
another output window. Yeah.
Yeah, let me show the output that it's open now so we can um have an understanding of what is happening there. Where's it again? Output. Okay, this is my output. Right. Okay, so this is the outputs now. This is the output. So this was what I just did now. Descriptive. If you look at it, everything I've been doing has been showing here. Sort cases by group D, sort cases by group A. These are all the things I've been doing. They are all here. And then this is the mean. So this is the mean for the liver. Don't forget we worked on liver. So based on this now, this is telling us that liver, there are 35. The n means we have um 35 values, yeah, under liver. And we can't go back to that. But if you actually check it, we have standard, control, all those like that. But everything is 35. That's what it's telling us. So we have 35 different values under that. And then the range is 3.26. Range is always maximum minus minimum. That's how we find the range. The maximum, and we look at it, we have the minimum, we have the maximum. So the range is the maximum minus the minimum. That's how we come about 3.26. And then the mean of all the data is 4.62, while the standard deviation is 0.836. Now, this thing alone can tell us, is actually telling us a lot of things about the data. One of the things it's telling us is that the range is kind of wide, because the range is a bit wide, because for us to have a difference of 3.26 between the minimum and the maximum, don't let us forget that we are working on these are spectrophotometers reading. Yeah, these are spec readings. So looking at it, there's a kind of a wide range between the values, but this is normal because different things may have caused that. It may be the different things that you are trying to read. So probably there's one that is absorbing more concentration while the other is not. So those are possible things actually. We don't need all those things really. And this is the standard deviation. Standard deviation is just trying to explain how wide the data are from themselves, from the mean. That is what standard deviation is trying to explain, but that is not all we are trying to do. But I'm just trying to show us how we can perform. So this is a descriptive statistics. It's just describing what the data is like. Okay, let me go back now. Back to the okay. Let me go back now to the data. Let me carry out another analysis for us to see. So I'll just have to go back to um. Okay, let me present something else. Back to the data that we're working on. All right. So back to the data. Now, that is one of the things. Now, let's say I want to carry out an inferential statistics, a common one, ANOVA. That's a common one we use. But one thing that is just okay, let me show us before I explain that. Now, I want to carry out ANOVA. ANOVA is a kind of data that has to do with comparing of means. So what you do in ANOVA is that you are comparing different groups. You are comparing their means with themselves. So yeah, now let's assume I want to carry out an ANOVA. Difference between one sample t-test and one away ANOVA is an ANOVA rather is that t-test is just between two groups. ANOVA can be between different groups. These are core statistics actually. We are not going there. So let me just quickly do a one way ANOVA for an example. Now the issue for one way ANOVA is that one way ANOVA requires a dependent factor. That is, yes, I want to find the mean, but I there is nothing on which basis am I trying to differentiate it in the sense
You
that
can't see the output.
I've not done anything, so it's still the same place. I've not done any output here. I've not done any output, so it's still I'm still on the same page, except that maybe okay. All right, let me share this thing so we can see. Oh, no, no. I'm sorry about that. Okay, this should be what I should be showing. Okay, can we see this now?
Yes, we can.
Yes, you
All right.
can.
So the focus is that I want to I want to find I want to compare by cannot read strings. The group is referred as the factor because for one way or another you must have a dependent list and you must have a factor. Now in this case your dependent list are all the parameters that you're trying to the organs, yeah, that you're trying to analyze. Your your factor now will be based on the group, but it cannot directly read the group. So there's a way I have to ensure to code it. Now, what coding it means is that I'm trying to give it a number, like I'm trying to give it a number, yes. So I can decide to say, okay, anything control, that's number one. Anything standard is number two. Group C is number three. So it will be easy for the factor to read that. So the factor would read what is based on numbers. Christiana, can I move on based on the time?
Yes, when this call ends, because this is actually a free version. So when this call ends, we are going to join using another link. So you can continue, sir.
Okay, okay, all right. So now I'm trying to analyze that now, and I have to ensure that I code this group into something that I can, that the ANOVA test can use as a factor. So all I just have to do is transform. So I just want to transform it. Oh no, let me use VR. Yeah, I can use this. Mm, okay. Okay. Yeah. Transform. Now I'm trying to change all those group into numbers that it will understand. So I can just, you can decide to use create dummy variables, or you can just use automatic record. Automatic record is faster. So if I decide to use automatic record, what am I trying to record? I'm trying to record the group, because it is the group that I want to change. So I can put the group into the variable name, and then I include the name. So I can say I can name it as group code. So having name it as group code, I add the new name, and then I press OK. All right, this is actually taking me back. Let me show you what we have here so that we can understand. Because I have a new window, the output window. So let me show you the output window for us to
Or
understand it.
should we try you sharing entire screen? I think if you share the entire screen, we should be able to, I mean, we should see how it proceeds from one
Out.
um, window to another.
Okay, then let me stop presenting it first. Okay, now let me see. Okay, is this better now? Well, I think it's displaying continuously. Or is this better?
It's still displaying continue. Yes, so can you now choose the window now? Are you sharing the entire screen?
Yes, I'm sharing my entire screen now.
Okay.
How is it?
Yeah,
Is it
you
better
can
now?
continue. Yes. Yes.
Okay, so
So you
this
can
was the
always
output.
follow.
Okay, all right. So this was the output that it showed me now. So what it has recorded it as is that control is now number one, number two is group C, number three is group D, number four is group E, number five is group F, while number six is standard. Recording is that recording changes those what do we call it now? Those string factor. That means those string group. It changes it to what was it called now? It changes to number to numeric so that we can exactly know, so that it can work while you're working with ANOVA. Now let's go back to what we were doing earlier. All right, so looking at it now, let me quit it now. This was what we did. So we already changed it to group code. I'm sure we all got it to this part where I changed it to numeric. Do we all get to that part?
Mhm.
Hello.
Yeah, I think you selected automatic record and then
Yes.
yes,
Yeah,
that was
exactly.
what we could see.
Yeah. So that was exactly what I did. That was all.
Okay.
So this has been changed to group codes now. So if I click on this, it changes it to their number, to the numbers. If I click on it again, it changes it back to the normal code. So I can now go back to analyze it. So analyze compare means one way and over. Now I want to work on kidney first, and then I want to compare the means based on the group code. So the group code will be the factor, and then we have to select a post hoc test. I want to believe that this is not the first time we're hearing about post hoc. Post hoc tests are just certain tests you have to consider even when you're trying to do an over. So each of these tests, the common ones we have LSD, Tukey, and Donut and Walla Dokan. Yeah, those are the common tests that we have. But in this kind of case now, what we basically focus on are these ones that we refer to as equal variance assumed, because that is what we often use. Equal variance assumed is what we often use for our test. Now it now varies between LSD and Tukey. Now there are various things that determines if we use LSD or Tukey, but oftentimes what we use in the biochemicals is Tukey's test. So I'll just click Tukey's test. That is what I want to do, and I already set my significance level to be 0.05. That's the common thing that we use in sciences too. You set your confidence level as 95%. So the this thing is 5%. That's your should I say on confidence now? That's our confidence level. Now this confidence level actually has a variance. add more things to it. But let me go into that. But remember that for most of our research, we always have statements like is statistically significant at p less than 0.05. This is all we are trying to. This is what we are just trying to say. So the significance level here that we are assuming that we've assumed here is that 0.05, and that's why it was default, because that's the common one. So the significance level is 0.05. Then we can continue. So after continue, now you can decide to pick options. Let's say you want to add other things to it. You want it to share, you want to get descriptive statistics from it again. You can decide to add that if you want. If you want the means plot also, you can decide to add the means plot, but I do not want the means plot in this case, so I can decide not to add it. And then continue. So having done all that, I can press OK. So I have my result here. Now looking at my results, these are the descriptives. That is for control. The mean of control is 3.6467. And the way we express our results in biochemicals is mean plus or minus SEM, right? And SEM is standard error. So this is mean, then your plus or minus is your standard error. So this is it for everything that we have here. Control group C, group D, group A, group F, and standard. These are the mean, these are the standard errors. Now, for you to now know if they are statistically different, that is, if they're actually different from each other, you use that is where the Tukey's test come in. So this is the Tukey HSD, which was the test that we did. Now, this is trying to show their significant difference. Now, for control, control is under one. Group D is under one and under two also. Group F is under one and under two. Group C is under two. Group standard is under two. Group E is under two. Now, what all this means, let me just quickly explain it, is that for your control, you can label one as A. So that superscript that you always see on results, this is where it all comes from. So for your control now, control is A after you've written your mean plus or minus SEM, then your superscript will be A for control. For let's say you want to do it orderly. For after control, let's say we have standard. For standard now, after your plus or minus SEM, the superscript will be B because it is under two. For C, for group C, which is the first, plus or mean plus or minus SEM, it is also under two. So that would be B also. Now for group D now is under one and two. So that would be AB. What this means is that, let me give an example. What this is trying to say now is that group C, which is only under two, that is B, is statistically significant or statistically different from control, because control is A. So group control and group C are statistically different. Control and standard is also statistically different. Control and group E is also statistically different, right? But looking at it based on the test that we have here, control and the group D is under A and B, so that means they are not statistically different. Control and group F are not statistically different also. If we are considering based on, we are using control to compare all the means. So for this result now, this is the interpretation. A1 means A, B2 means B. So that is exactly how that works. This is based on one way and over. Now, if you look at it here now, what we have is says the main difference is significant at the 0.05 level. That means if it is less than 0.05, then it is significant. If it is not less than 0.05, then it is not significant. These are just certain things that you may need, but the main difference between all the groups, this is the 95% confidence level. So now we have the confidence interval. Interval, we have to be the lowest at the highest, lower bound at the highest bound, or we can also say the lowest possible values and the highest possible values. These are what we have here um, as the 95% confidence interval. Although most times we don't really consider all these things while bringing out analysis, but those are some of the things that we can show. All right, so this is exactly how the one way ANOVA looks like. Now there are different ways people decide to show their results. One of the ways people use, let me show that of the one I did. Um, is it here now? Okay. This is the one I did. Can we all see the screen?
Yes, yes, we can see it. This is the entire screen, so we can see
Yes,
it.
you can see it.
All right. So this was the results I give the person after he completed all the analysis. So if you look at it now, we have the parameters, we have the liver, kidney, and the significance are all there using the superscript. So that and looking at it, values are expressed as mean plus or minus SEN. Superscript shows significant difference. So that is how everything works. The organ body weight, hematology results, the weight result, and then we have some graphs. All these ones are different. So that is just exactly how it works. There are other things, yes, there are other things involved really, but it's quite in a number of things that I may not be able to explain everything here, but that is just how, or that those are just the basic steps that we take while carrying out analysis using SPSS. So I want to believe use from SPSS to carry out analysis, especially for biochemical analysis. So I don't know if there's any question, so I can take the questions before I take my leave this evening. But I want to believe that we've learned something, please. Can I assume that?
Yes, I mean, it's beyond an assumption right now. I had to, I actually had to bring out my own notes as well and, take notes. I'm familiar with using GraphPad, but not SPSS. I remember when we were being taught, I was not getting But this was though
Wow.
a short
I,
class,
I
but
remember, yeah, then
you
so I
can
didn't
relate,
actually
right?
understand it.
This is actually a short class, but I mean, a short but deep, right? So thank you very, very much. We are going to be taking just two questions, right? We'll be taking just two questions because our guest, I mean, our facilitator has another important meeting. And so if you have other questions, we can send it to me after and I'll get it through to him and get you your answers. So any questions? The first two to raise their hands, I think. Yeah, let's do it that way. So if you have a question, you can raise your hand. Or we do not have any questions. Okay, I can see John's hand. Okay, John, go ahead, please.
All right. Good evening, everyone.
Good evening.
Good evening.
Thank you so much for this wonderful presentation. It's a very good one. And my question goes like this: from the descriptive statistics, we took an example from I think the liver, from the organs as the liver. Are we together?
Yes, we can hear you.
Yes.
Yes. My question is that how do we get to know the mean, the standard deviation for each group? Because I don't know the mean there and the standard deviation and the other parameters under the descriptive statistics does not show um, for the individual group. It just show a
If
single
you have to
um,
be choosing it
value, a
per group
single
now.
value. I don't know whether you understand what I'm saying. How do you get to know for each group?
All right. Yes, I understand your question. Okay, now what descriptive does? Descriptive just helps to explain the whole of the data. That's what descriptive does. So descriptive does not like categorize it okay for control or group. No, descriptive analysis does not do that. It describes the whole of the data altogether. So if you observe earlier, the descriptive analysis we did, the n that is showing the number of entries that we have there was 35. But for the one we did later, this one had to separate it based on the group. So that is what ANOVA does. ANOVA calculates their mean by the group. So that's the difference between descriptive and ANOVA. So oftentimes, biochemical analysis does not use descriptives. The only people that often use descriptives are, let's say, those that probably those that use questionnaires. Yeah, they are the ones that often use descriptives. That is to check, okay, how many people answered very good, how many people answered. That is what those that actually use descriptive. But for biochemical analysis, and we're trying to check the mean, we don't use descriptive. So you can just use ANOVA without a Tukis test. That's fine. But all you will just get is just the mean and the standard error. Do you understand? So the post hoc test just tries to, that means the tricky says that we did, tries to show their statistical difference. Like, are they truly statistical difference? That is what the tricky test does. So let's say you just want the mean by group, you can just use a direct ANOVA. You don't need a statistical test. Was I able to answer your question, Mr. John?
Yes, sir. Thank you so much.
All
Thank you
right, you're
very much,
welcome.
sir.
Okay, one more question, and we're going to close for the night. One more question. One more question. Anybody? All right, I'll take
Yes, yes,
that
please.
as
I have a
oh,
question.
okay, okay, very quickly, please.
Okay, yes, I want to ask about the installation. If you want to get this software, like how do we go about it? Because there was a time I was trying um to get it installed to my system, but I couldn't do it.
Okay, to get it installed, actually, oftentimes they are paid versions, actually, because that's all these things. The one I have before to add to was a paid version, but there's a way you can always get the cracked version. Now, one easy way is probably you have someone that has it. That is the easiest way. But provided you don't have someone that has it, there's a site where you can use to download it. The site is getintopc.com. Getintopc.com. Now you have to ensure that your what's it called now? Your system is at least Windows 10. That's very, very important. At least Windows 10 and at least 4 gig RAM. Yes, it must be at least 4 gig RAM too. So once those two things are in place, then I think you can and get it downloaded. So all you just need to do is go to that site, get into PC. Now, then you search for SPSS. It will bring out IBM SPSS. So before you download it, there are certain there's a video there that you should watch. The video there would explain necessary things you need to do because it's not a direct setup. It's not a direct installation. Actually, it's not. And that installation actually is for people that actually like people that are can that actually knows how to use computer well. Yeah, because they are kind of technical. So it's a kind of technical way to install it. And by the time you install it, you won't have to pay, but it's quite technical. But if you follow the video, I believe you should be able to do. And even if you are not able to, you can get someone that would always probably understand those technical jargon that will be in the video and still be able to help you go about it. But the ordinary one is that you have to pay for it. But there are always cracked ones, so you can get from getting to PC. And then there's a video there. Just ensure to watch the video and you'll be able to know how to navigate it. Did I answer your question,
Okay,
Sir James?
thanks so much, sir.
All right. Yeah, you're welcome.
Yes, yes, thanks so much.
All right, thank you so much. What are we saying to our facilitator? Please let's thank him very much, because I know how much people are paying to get this, and he
Thank you
agreed to
so much,
come
sir.
take us. Yes, so please let's appreciate him. Thank you so much, so much, so much, so much. Thank you. And just so you know, if you would like to delve deeper, all right, you like to, I mean, we've done a basic class, and you've seen, like I told you, I explained to you from the start that Mr. Olusegun is a teacher. You know, there are people that just dispense words, but there are some people that impact, right? He impacts, and you, of course, you could see it, right? So if you would like to go deeper in it and learn more, you can let me know. I'm going to even send in details, right, for trainings that he has that are available presently, and it's very affordable, very, very affordable. And you can get this knowledge and help your mates in school with their project analysis, and you can decide to also charge them, because a lot of persons find it difficult to analyze and it gets them confused. Well, if you tell them, oh, don't worry, I'll help you do it. Just bring 30K, just bring 40K. They'll be happy. So far, you can give them a perfect, I mean, yeah, an excellent work. And that is it. You have to pay money to gain knowledge. You have to pay money to make money. But then I want to say that I really appreciate our presence here. Thank you so much. And before we leave, let me just drop some details. So we are going to be, it's quite, will I say, it's quite sad
Um,
that we'll have to,
Christiana,
okay, yeah, we can release you. Should we let's release our facilitator, please? Let's end in the applause. Thank
all
you
right.
so much.
All right. Thank you so much for
Thank
having me. I
you.
sincerely appreciate that. This is just for some, like, in case you have anyone. Just like I said, I didn't have a background in data analytics. I'm a biochemist just like you, and I right from school I didn't really have an interest in data analysis because I felt it's all maths. So and most people, since I started the training, most people have been reaching out to me about, do I have to know maths, all those things. So one of the things you want to do is that if you feel you actually have interest in data analysis, but you are scared of the maths, there's a webinar that will be coming up next week, Sunday. I will share the link with Christiana so that she can, anyone that is interested, it's just a webinar to open your eyes that it's not always about the maths. So it's a webinar. So that's one. And secondly, provided we have people that are interested and wants to learn, we can actually come in group as a way to help you guys. Yeah, I feel that would be easier. So you can come in group and we'll just find a way to get something done. So I think that would make it easier and that is affordable for most of you. So if it's group too, there's no problem. So if there's anyone, please you can always reach out to Christina. She can always get across to me. So thank you once again for tonight. Really appreciate it. I wish you all success. I wish you all great success. Thank you and a wonderful evening to you. Thank you so much, Christiana. God bless you.